So yesterday we were discussing a question which we were not able to complete. I'll write down the question again and then we can talk about it. So basically we were talking about coordinate geometry, particularly the section in which we were solving problems involving intersections of lines and circles, right? So here basically you will see that you'll be having a line and a circle and you would be finding the intersection points and stuff like that, okay? So let me just write down the question. So the question is, the line x equals 3y plus 10 intersects a circle which has the equation x square plus y square equals 20 at points A and B. Okay. So basically we did the first part. In the first part, we had to find points A and B. That was part A. We will not do that again. So basically we solved this equation and this equation simultaneously in order to find the points of intersection, right? The line intersects the circle. This is the equation of the circle at points A and B, and we were able to find A and B using a simultaneous equation. So A was -2 and -4, and B was 4 and -2. These were the coordinates of A and B. Okay, let's talk about the second part. So basically in the second part, you need to find the equation of the perpendicular bisector of AB and show that it passes through the center. Okay. So what is the question? You need to find the equation of the perpendicular bisector. Now, I have been telling you guys that whenever you have been asked to find the equation of a line, perpendicular bisector is a line that will bisect AB. It is going to be basically a line, and whenever you have been asked to find the equation of line, you need two things. What are those two things, Gayatri? Yes, you know this. We discussed this part yesterday as well. Any idea?
Yes, I can't listen your voice.
Can you hear me now?
Yeah, now it's better.
Okay. So basically, we need to find the equation of the perpendicular bisector. Ishal, can you hear
First,
me
we have
properly?
to find the gradient.
Okay.
Gradient of AB.
Yes, gradient. Okay. And gradient of AB. Okay, then.
Then midpoint.
Very good. Midpoint of AB, right? Okay. So basically, you want to find the equation of the perpendicular bisector of AB specifically. Are you going to use the gradient of AB directly, or you will do something with this gradient to find the gradient of the perpendicular bisector? You will use the relationship that gradient of the perpendicular bisector multiplied by gradient of AB equals -1, right? So here you will use the gradient of AB. So please find the gradient of AB, Ishal and Gayatri, both of you. And tell me your answers, okay? You have time. Find the gradient and tell me the answers. I'll write down the formula for you. It is y2 minus y1 divided by x2 minus x1. And I told you, you can use any point as first point and any point as second point. So you can think about it as x1 and y1, and this is x2 and y2. Okay, just find the gradient and tell me your answers. What is the gradient of AB?
One upon three of the gradient of AB.
Okay, that's correct. It is basically 1 by 3. Very good. Okay. So what would be the gradient of the perpendicular bisector, Ishal?
3.
Who's that?
It's me, Gayatri.
Okay. No, it is not 3. Yes, Ishal, what would be the answer? You have to use this relationship. This is the gradient of the perpendicular bisector, and this is the gradient of AB, which turned out to be 1 by 3. So what would be the gradient of the perpendicular bisector? Any idea? Yes, Ashal, can you hear me? Please answer me, please, that if you can hear me or not. Okay, so the gradient of the perpendicular bisector would be -3. Okay, this is the negative reciprocal of this gradient. So it is -3. Okay, so this would be -3. And we have the gradient, we need the point, and that point would be the midpoint of AB. So how do we find midpoints? Basically, the midpoint of AB is going to be a point with x1 plus x2 by 2 and y1 plus y2 by 2. So what is x1? -2 plus 4 by 2. And what is y1? -4 minus 2 by 2. So it would be, what is the midpoint? 1 and -3, right? Now we have our midpoint, we have our gradient. What would be the equation of the perpendicular bisector? It is y minus y1 equals m x minus x1. So it would be y minus, what is the y point? It is -3. What is m? M is also -3. What is x1? It is 1. Okay, so this would be y equals -3x. Okay, this will go there and this would also be negative. So the answer would be y equals -3x, right? Did you understand this, both of you, Gayatri and Ishal?
Yes.
Okay. All right, let's talk about the next question. That basically is the C part of this. So we'll write down the answer to this part. Okay, so this turned out to be y equals -3x. Right, so let's talk about the next part of this question. This is the last question of this chapter. And this question is just like the questions you will have in your exam, okay? It's of the exact same type. Okay, so let's talk about the third part then. We have the perpendicular bisector of AB intersects the circle at points P and Q. Okay, wait a second. Before talking about the third part, we need to talk about this part as well. Show that it passes through the center. So basically, we need to show that the perpendicular bisector of AB passes through the center of the circle. So what is the center of our circle, Gayatri? If this is your equation of the circle, We know that general form is x minus a square plus y minus b square equals r square, right? And the question or the equation in the question is x square plus y square equals 20. So what can we interpret? Can we say that a is 0 and b is 0 in our equation, right? We don't have any number here and here. This means that the center is 0, 0. So basically they want us to show that the perpendicular bisector passes through the center. This means if we will use these points in the equation would be satisfied because this point lies on the circle. So this point would satisfy this point lies on the line y equals minus 3x. So this would satisfy the equation of y equals minus 3x. So we can use x equals 0 and we will see that we get y equals 0, right? So y is minus 3 into 0. That would be 0. This means that x equals 0 gives us y equals 0, and this implies that this point, that is the center point, that is 0, 0, certainly lies on this line. Okay, did you understand the second part of part B? Yes, Gayatri and Vishal? If not, then feel free to tell me that I did not understand this, please. Okay, Gayatri has understood this, and what about Vishal? Please tell me. Okay, let's talk about, okay, the third part. So the third part says the perpendicular bisector of AB intersects the circle at points P and Q find the coordinates of P and Q. Okay. So how can we find these coordinates? Let's read the question first. It's coordinates. Okay. Now what is the question? The perpendicular bisector of AB intersects the circle at points P and Q. Now, whenever you come across such a question where they are telling you that there is an intersection, right? So the intersection is between what and what, okay? Perpendicular bisector of AB, this thing, this is the equation, and the circle. So for circle, this is the equation, okay? And you need to find what? You need to find the points of intersection. This is very simple. You have the equations for both the things. The equation of this perpendicular bisector is y equals minus 3x. This is what we calculated in the previous part. And the equation of circle is x square plus y square equals 20. So just like the first part where we had to find the points of intersection of this line and this circle, and so we solve them simultaneously, this time we will solve these two equations simultaneously and find their answers. Okay, so we are going to do it this way. So we need to solve these equations simultaneously. This is the first equation. This is the second equation. How do we solve equations simultaneously? We can use y equals minus 3x in 2, right? This is 2. So 2 is x square plus y square. Instead of y square, I can write down the value of y, that is minus 3x, and then its square of y equals 20. This will give me x square minus 3 square would be 9, and then x square equals 20, and this will give me 10x square equals 20. Finally, I am going to have x square equals 2, and then x would be plus minus under root 2, right? Again, I repeat. Here the question was to find the points of intersection of the perpendicular bisector and the circle. So the question could be of any type, but every time you would have to find the points of intersection. All you need to do is you need to have the equations of this thing that is coming before this word intersects and the thing that is coming after the word intersects, right? We had the equations. This is 1, this is 2. We have to solve them simultaneously. So we have used y equals minus 3x in this equation, and we got the values of x as plus minus under root 2. Okay. Once we have the values of x, we need to find the values of y. Okay. So we can use equation 1 or 2, any equation, but it's much better to use 1 because that's simple equation. So it is y equals minus 3 under root 2, and it would be y equals minus 3 minus under root 2 because we have two values of x, right? So this would be minus 3 under root 2 and this would be 3 under root 2. This means that for x coordinate under root 2, y is minus 3 under root 2, and for x coordinate minus under root 2, y is 3 under root 2, right? So this could be p and this could be q, or it could be other way around, right? We are not sure which point is p, which point is q, but it's totally your choice, okay? So these are the answers. Did you understand this? Okay. And what about other students other than Gayatri? Yes, Ashal, did you understand this? Please answer me. Haris, did you understand this example? Okay. Haris, I will share the recordings with you because you joined late, इसलिए आपको समझ नहीं आया. All right. Let's talk about the next chapter now. That is circular measure. Okay, now this is a very easy topic. And if you were good at it in O levels, you would be able to do it here as well. Okay. It is the fourth chapter. Okay. So basically, since the chapter is circular measure, we'll be talking about circles. And first thing is section 4.1, that is radians. Okay. Now this is very simple. You need to understand one thing, that in this section we will see we can measure any angle by using two things. Okay, two units. Like we have centimeters and meters. we have liters and milliliters, we have kilometers and millimeters, right? We have degrees in Fahrenheit, we have different units, right? So here you will see that you can measure angle not only in degrees but also in radians. Okay, so this basically means, let's say if this is the x-axis and the y-axis, if I talk about this blue line, okay, the angle between the blue line and the pink horizontal line is 90 degrees, okay, and this is measured in degrees. If I talk about this line, it would be, let's say, for example, it would be greater than 90 and it would be less than 180. So let's say it is 120 degrees, right? Again, I'm measuring in degrees, okay? But it could be that in the question, your range is given in radians. When we talk about radians, your values are basically in this type. It is pi or it is pi by 3. It could be 2.01, something of this type as well. So this is different than radians. And it is very simple. You can easily find your angles in radians. How? You just need to know one relationship and you are good to go. Just remember, always remember that pi radians basically equal to 180 degree. Now, when I say pi radians, don't get confused. What is the value of pi? It is 3.14, right? So I'm basically trying to say that 3.14 radians equal 180 degrees, right? But we write it as pi because we don't have to write down the exact value of pi. We can just use pi and we will get the answers, okay? Acha. If this is pi radians, what would be 90 degrees then? What would be the value of 90 degrees in radians? So it would be x radians, right? How do we solve such questions? By using ratio proportion. So we will simply cross multiply, and what do we get? 90 degree into pi equals 180 into x. So 90 by 180 into pi equals x, and x is 1 by 2 pi, right? So x is basically, x is pi by 2 radians, right? So did you understand the basic concept of this section? That we will be converting the angles from degrees to radians and from radians to degrees. Yes, Gayatri, Haris and Nishal, this is a new chapter. Please think about it as a new beginning and try focusing on this. Okay. What about other students other than Haris? Gayatri, did you understand this? Please tell me honestly. Okay. All right. So, Ishal, I guess you're not there in the class because I'm asking you continuously and you're not answering. Okay. So, this is the relationship which we will be using, right? Okay. Yes. Pi radian is always 180 degrees. This is a standard, okay? Yes, standard. है. अब you will see how are we going to find all the angles in radians using this relationship, okay? So let's see what is the value of 45 degrees in radians. What is the value of 30 degrees in radians, and what is the value of 18 degrees in radians, right? Okay. So let's say that we have 45 degrees. What we do is, again, pi radians. This will give you your angle in radians. This will give you your angle in degrees. Pi equals 180. 45, and then we don't know what is the angle in radians for 45 degrees. We will cross multiply. 45 pi is going to give you 180x, and x would be 45 pi by 180. And what would be the value of this? This is 1 time and this is 4 times. So this is pi by 4 radians, okay? This means that if I talk about 45 degrees, it would be somewhere here in the middle of 90 degrees. So it would be pi by 4 radians, right? Now you know that you can write your answer both in degrees and radians, okay? Just like you can convert temperature, just like you can convert any unit to other unit, that this is how we are converting from degrees to radians. And the last one is, sorry, the second last one. Now I want you guys to find the answers and tell me what would be the angle in radians for 30 degrees. Hmm. Yes, Ishal, Gayatri, and Haris. Use the same relationship and find the value of a B. What would be the angle in radians for 30 degrees?
Six pi.
6 pi or pi by 6?
That's pi by six. Sorry.
Very good, okay. So this would be pi by 6. And Haris, what would be the value in radians for 18 degrees? It's simple, just do it this way. Pi into 18 divided by 180. You will get your answer directly. There's no point in doing that cross multiplication every time. So the value is pi by 10 radians. Okay. Now this was basically converting the angle from degrees to radians, and now you need to convert the angle from radians to degrees. Okay, let's talk about that in the same section. Let's say that you have been asked to convert from radians to degrees. First part is to convert pi by 6. Second is to convert 2 pi. Third is to convert pi by 10. Okay. Now, yes, this is the relationship, and yes, you can use the ratio proportion method, but you won't be having that much time. Okay, so I will write down two notes here. Think about them as the formula, and you can directly find the answer. So, since we're talking about converting the angle from radians to degrees, what you need to do is to change from radians to degrees, multiply by 180 by pi. Okay, this is basically your conversion from radians to degrees. Multiply your angle by 180 by pi. For example, let's talk about this question. There's no point in writing down the ratios and then equating them and then doing it. That is very time taking. So your answer would be simply pi by 6 multiplied by 180 by pi. Okay, we are using this formula. Pi and pi would be cancelled, and 180 by 6 will give you 30 degrees.
30.
Very good. Acha, let's find this one. Again, simply 2 pi is the angle in radians. We will multiply this with 180 pi. Pi would be cancelled. 2 into 180 is 360 degrees. And this makes sense as well. If this is pi, then obviously this would be like in total, this would be 2 pi, right? Because we know that it is double 180. So if it is 180 for straight line, for the complete circle, it would be 360. So basically it is 2 times what we have for a straight line. Okay. And what about this one, last one? Tell me the answer quickly. Simple multiplication of this angle with 180 by pi would be cancelled, 10, 10, and like they are cancelled, and your answer is 18 degrees. Okay. So this is how simply you can just convert your angle from radians to degrees. Okay. And if I write down a similar note for the previous conversion where we had the angle in degrees and we wanted to convert it in radians, it would be to change from degrees to radians, multiply by pi by 180. Okay. This is the formula and this is how we do it, right? Did you understand this section completely? 4.1. Every student, Haris, Kaitri, and Vishal.
Yes.
Okay. And what about other students? Okay. Then let's talk about. Okay, Haris. Then let's talk about some more examples. This is example 4.1. Let's say that your question is change 5 pi by 9 to radians to degrees. Okay. So how do we do that? How do we convert our angle from radians to degrees? By multiplying? By multiplying what? 180 by pi. Okay. So the answer would be 5 pi by 9 multiplied by 180 by pi. Pi and pi are cancelled. 9 1 times is 9. 9 20 times is 180, and the answer is 5 into 20. 5 into 2 is 10, and then we have 0. It is 100 degrees, right? Okay. So that is it. Now in questions, you will see that we will be using radians frequently, right? So it is very important for you to understand some of the popular angles which we will be using, just so things are easy for you. I'll write down for both degrees and radians, and then you would be able to understand it. Okay. So basically, I'll write down the angle in degrees here, and then we'll see its conversion in radians. And then you have to get comfortable with this because this is what we'll be doing in this section. Okay. So if we have 0 degrees, I will write down the angle in degrees, and meanwhile, you can just find your values for radians. If we have 30 degrees, if we have 45 degrees, then we have 60 degrees, then we have 90, 180, 270, and 360. Okay. So 0 degrees is basically equal to 0 radians. 30 degrees is basically equal to pi by 6. 45 degrees is equal to pi by 4. 60 degrees is equal to pi by 3. 90 degrees is equal to pi by 2. 180 degrees is pi. 270 is 3 pi by 2. And 360 is 2 pi. Okay. So this is how we convert this. Okay. Anything that you have not understood? Okay. Now, basically, you guys must be familiar with things of this type where you have to find sine 30 degree, or let's say sine 45 degrees and stuff like that, right? But remember, when you are doing it on your calculator, you can basically convert the mode. Okay, when you will do sine 30 on your calculator, and if you are finding that small d on it, right? Do you have your calculators in front of you right now? Can you please take out your calculators? And now if you look at it, you will see that sine 30 will give you 1 by 2 if you have that small d on your calculator. That small d basically means that you're working with degrees, okay? Let's convert this to radians. So you need to press shift, then mod button next to the on button. Then you can see that you have 1, 2, 3, 4, 5, 6, 7, 8, right? For 3, you have degrees, and for 4, you have radians. Now, if you will press 3, your answers would be calculated using degrees. And if you press 4, your calculator is basically changed to the radians mode. Now, when you will do sine 30, you will get wrong answer. So you need to do sine and then the value of 30 equivalent to radians. So what is that value of 30? It is pi by 6. Okay, now do pi divided by 6, and again you will get 1 by 2. And if you do sine 30 on radians mode, you will get negative 0.98 something. That is the wrong answer, right? So this is extremely important to find your values using the calculator. For example, let's talk about the last question. Let's say you have been asked to find the value of sine pi by 3 and tan 1.5. Now this 1.5 and this pi by 3, both of these are your values in radians, right? This is obvious, and this I'm telling you it's in radians. So in order to find this, first convert your calculator to the radians mode, then do sine pi by 3. This will give you under root 3 by 2. And if you do the same thing for tan 1.5, you will get 14.101. This would be 14.1, right? So this is very important that you have the correct mode on the calculator while doing trigonometry, okay?